Today we're going to talk about building universal web apps with React and lots of other JavaScript libraries. You can find me on Twitter, on GitHub. The code is at that bit.ly. The slides are also linked on the README of that repository, which is called Complete Isomorphic App. That repository comes from a book I'm writing on the same topic, which goes into way more detail than we can cover today. You can get it 40% off. You can also enter your email in a form there that I've linked to, and I will raffle 3 free ebooks later. I'll send you an email. I'll leave this up for like 10 more seconds, 20 more seconds. I work at Vivo. I'm the web lead there. We've been building isomorphic apps for about 2.5 years, which is a pretty long time in the universal isomorphic app world. In fact, we started before Redux and things like Redux and React Router were that popular, and ended up doing a rebuild so we could be on a modern stack. So you'll notice that I'm going to switch a lot between universal and isomorphic as I talk about this topic. For all practical purposes, they mean the same thing in this context. There's a big debate raging online about which one is more accurate. In my opinion, neither of them are 100% accurate. You can use the one you like. I think people will understand you at this point. But basically, they both mean we're going to write code once and run it into environments. In this case, Node being the server, and your browser, all the browsers. So today, we're going to talk about a bunch of things. We're going to start with an overview of what this means beyond the definition I just showed you. We're then going to talk about why you'd even want to build an app like this. Then we'll walk through all of the libraries and tools we'll use to do this, and we'll walk through building one route on the example app all the way so that it truly isomorphically renders. And at the end, I'll talk a little bit about some of the challenges and trade-offs with this type of approach and try to suggest some solutions, although as we'll talk about, there is some complexity pieces here that haven't been 100% solved yet. So, what is a universal app? Well, let's back up for a second and talk about the kinds of architecture you might use to build a web app today. So, the one that's been around the longest is server-side rendered applications, right? So our user comes to the browser talks to the server talks to your database or API or backend, whatever it may be, gets the data for the page or part of the app your user is requesting, and then sends the whole page completely rendered back to the browser. The problem with this is now me as the user, if I want to do anything else, we have to go through that whole round trip every time we want to update anything, right? So for a while now, we've also had single-page applications, right? jQuery, Angular, Backbone, Ember, React, you name it, right? So in the single-page application flow, the browser talks directly to our backend via Ajax and gets the data and populates the views. And this means that when the user wants to route or make updates, do any kind of interaction, we don't have to do that whole round trip to the server. And this is great, and generally it's pretty fast. But it has some challenges, especially with performance on initial load and with SEO, which we'll talk more about in a minute. So why couldn't we have the best of both worlds, right? Get a really good initial load and then have a nice single-page application experience for your user once they've loaded the page. And that's kind of the idea with universal app architecture. So in this case, the user comes to the browser. This one's going to look a lot like our server side from a couple slides ago. They're going to go to the server. The server's going to fetch the data. That's going to come back, and we're going to render the page. Except we're going to do something extra here. We're going to take that state, which is represented by whatever data we fetched and set up, and we're going to also send that back with the entire rendered page. Then the browser is going to take that state. It's going to use it to rehydrate which just means that we're going to build the application state again to match what's sent down from the server, but in the browser, so that we can now listen to user actions and use Ajax and do whatever else we want to do, but just from the browser. And then we can talk directly to the backend. So this is pretty powerful. So the first reason this is powerful is for SEO. Now, I don't know how many people here work on like public-facing product-type apps, but if you do, SEO is really important. And in my example, if you want your cat video to show up first in Google, you really need good SEO, right? So otherwise, YouTube's going to beat you because they have all the cat videos. With like Angular or other single-page application architecture, Google may not actually see all of your content, and that's really bad. And there are ways to work around it, but none of them are great solutions. So with this type of architecture, you can have Google get your complete page, which was rendered on the server. But it's also good for your users, because your users are going to see something really soon after they load the browser, load your page in the browser. Because you did all the work on the server, you're sending them a completely rendered page. All the browser has to do is actually make it visually available to them. There's no JavaScript loading required. There's no round trips required. It's just there, which is really good. Of course, we still actually have to load the JavaScript, so that's why we call it perceived performance, because there's probably a delay that if you're fast enough, you could detect between when you can see it and when you can actually interact with it. So that's a trade-off you're accepting for this type of flow. There's also a lot of maintenance and developer benefits. This is my team and some other people on the general team at Vivo. We went to Escape Room. It's really cool. You should do it. But we get to only write in JavaScript, and we don't have that context switching. We also can write like the same helper code for both our server and the browser, and you get a lot of code reuse out of this and don't have duplication. We actually had an app previously that was written in Angular that did some of this state sharing between the server and the browser, but because of the way it was written, had a lot more code duplication between the two, and in this type of architecture, you can really cut down on that. Okay, so that's why we'd want to do it. But now, how do we actually do it? So real quick, I want to take a survey. How many people in here like actively work on React at work? Okay. And do people use Redux and Webpack? Or anybody went to the Webpack talk in here previously? Good. We're also going to use React Router and Node. How many people have experience with Node? Cool. Excellent. So as you can see, we need a lot of things to do this. So let's walk through each of those things and talk about why we're going to use them. So we're going to talk about that, and then we will also talk about how to build the cart page in our sample app, which, again, the code is at this bit.ly link, universal-app-react. So you'll notice on the slides in the rest of the presentation that I'll have one of these two icons in the corner if there's code on the slide, and that indicates whether the code will run in the server, the code will run in the browser, or the code will run in both. Right? The browser icon is the one on the right, the server icon the one on the left. So that's to help you try to keep track of, what parts of this have to be done in what environment and what parts are shared, because that can get pretty confusing when you're first learning this. So this is my sample app. It's called All Things Westies. It's like if you wanted to go buy specialty products about your dog. A Westie is a small white terrier. I have one. I thought this was like a bit ridiculous, but then I did a little research, and this is a real thing. In fact, there's like all kinds of specialty pet sites, and whatever kind of dog you love, you can find stuff for them. So, So first, really briefly, we're going to use Node and Express for this. I'm not going to go into great detail about this. It's there. It runs the server. Most of what we're going to do is going to be in an Express middleware. We're not actually going to handle really any routing in Express. Express is just going to be a generic catch-all router for us, and then we're going to pass it off to other libraries. If you want to see what's going on with this, it is in the example code. So we're going to use Webpack for this. And the reason we need to use Webpack is because we want to end up with code that can run in both environments, but a lot of the code that can just run on Node can't just run in the browser, right? Like, I can't just take some NPM modules like React and set my code up and then expect it to run in the browser. The browser doesn't know what to do with that. I also can't just write ES6 or ES7 and have it work in all browsers, right? So I need some things that handle this, even though the Node side, at this point, if you're using Node 6, most of these things can be done pretty easily on the Node side, maybe just with a little Babel configuration for JSX, but we do need Webpack for the browser. So there's a couple other things why we want Webpack. You can actually bundle CSS into your browser bundle, which can be an advantage depending on what your performance needs are and other needs are. And then there's a lot of advanced features like you can make sub-bundles so you can only load part of your site. And like Webpack dev server is a really powerful dev tool, lots of cool stuff. So Webpack basically works by taking your code, parsing that code into a bunch of like AST dependency tree, essentially, applying a bunch of loaders to that code, and then outputting, in the case of this app, one single compiled app file. In the example app, there's basically one script, npm start, and it runs Webpack, and then it runs the server. Webpack runs this Webpack config. And the Webpack config just lets you specify an entry point. So that's going to be main.jsx. Main.jsx is a file that will only ever run on the browser. That's important if you need to put any like browser-specific code in there that talks to window or document. Then it outputs the file, and you can turn on source maps. That browser.js we'll use much later when we actually load the full site off the server. So we need a couple loaders for this project. You need Babel because we're going to use ES6, and we have a little bit of CSS packed into our Webpack for this example. Okay, so we're going to use React, as you probably could tell by the title of the talk. React's a powerful tool. Looks like a lot of people here use it already. React has this thing called the virtual DOM, and the virtual DOM has really changed web development in a positive way. But the virtual DOM is also what makes it possible to do this isomorphic flow without like a lot of overhead. So React keeps track of your component tree. So here you can see like on our cart component, we have some sub components here. And it has this tree. And when you want to make a change, like to our list of cart items, then it calculates what the difference is going to be, and then is able to intelligently update your DOM. This is really important because on that initial render, that first time when we get it off the server, we want React to build the component tree in the browser and then say, hey, actually, there were no changes. We're just going to leave it alone until the user interacts with it. Because otherwise, we'd be doing a lot of wasted re-rendering once we get to the browser, even though the page is already there as it should be. So in the browser, you set up React by calling react-dom.render. You just put your root component there, and you attach it to somewhere in your DOM tree. But React also lets us do this on the server. Of course, there's no DOM on the server, so we're not going to attach it to the DOM. Instead, we use render to string, and we output a string representation of the HTML components that will eventually pass back down to the browser. So we're also going to use React Router for routing. Like React, it actually provides both a browser and a server implementation, which is really important here. React Router actually lets us reduce a lot of duplicate code by not having to set up routers separately on the server and the browser. So in the example app, you have some basic routes, products, cart, profile. You also have like login. Also, if you're actually running the code, a lot of this stuff doesn't fully work. The main cart example we're talking about fully works, but other things don't yet. Book is in progress. So React Router is going to render in the browser very similar to how React renders. In fact, we just use it as our root component instead of whatever our root component was before. And now we go to any of the components that match a route, so cart or products. On the server, it's a little bit more complicated, but it does use the same routes. So you set up routes once, you use them in both places. So on the server, React Router provides this function called match, and we can use the match function inside of this middleware we've created. So the match function is basically going to take in some routes and the current location, and then call a callback that tells us if the route matches, and then we can decide what to do with it from there. So we just take our routes, pass it in, take the location off of the request object, and then inside of our callback, we're going to make sure there's no error, make sure there's not a redirect, and then if there is actually a route match, then we'll do some code rendering. We'll get to that in a minute. So we're also going to use Redux. Unlike all these other things, Redux isn't being used because it's specifically good for a universal app or isomorphic app. Redux is just helpful in building large-scale React applications because it manages your business logic for you. You don't have to use Redux, and I actually had a version of this talk a year ago that doesn't, so you can find that on my GitHub if you want to see a non-Redux implementation. But Redux makes our lives pretty easy here. If you're not familiar with Redux, I'm going to go over this pretty high level today, but there's a lot of good tools online where you can learn more about this, and I recommend digging into this if you haven't used it before. So Redux is going to let us call it from the view. So in the view, we'll have an action, and we'll call the action. And that action will then trigger something that's called a reducer, and the reducer updates the store. So the idea is that data can only flow out of the view to the store, and then eventually the store can update the view again. But it only has single directional data flow. If you've used some other web frameworks, you probably know that they often do two-way binding, which is confusing and harder to find bugs in. Single direction flow is very helpful. Also, everything in Redux is pretty functional. Like we'll see in a minute, the reducers take in an action and the store and output a new copy of the store so that you don't have any like bleed between states. Okay, so that was a lot. We covered a bunch of libraries that we're going to use here. Yeah, this is why people write about JavaScript fatigue online. So now let's put it all together and build up a cart experience. So this is our cart. The idea here is much like if you were on Amazon, you could go shopping and then be like, I'm not sure if I should check out right now, leave for a while, come back, and we'd remember what's in your cart, which means we had to store it somewhere persisted in our API, and when you come back, we can load that data on the server and then give you a very nice perceived performance experience. Arguably, the cart would not be served to Googlebot, but it's just an example. So first, we need some routes. So these are all the routes that are currently in the application. React Router uses JSX, just like React does. Routes are just components. We tell them what the path is and what React component should be rendered on that path. And if you look at the code in the example, you'll actually find that this is returned from a function. This is because it's testable and also because later on, if you want to add some more advanced features, you might want to tweak things slightly between the server and the browser, and wrapping in a function lets you do that because you can pass different things in the different environments. So we also need to build some components. So we need to build the whole cart that you saw. We're also going to build this cart item component that goes in our cart list. So this item is a pure React component. So we're just going to write it as a ES6 function. It takes in some props, right? In React, props are passed down from your parent. In this case, the cart is going to take care of fetching the cart items. So we just pass some stuff into item. If you're not that familiar with React and JSX, it pretty much looks like HTML, but there's a couple key differences. Make sure you always write class name. That's a major gotcha if you're just starting with React. All of this becomes JavaScript at some point, and class is a reserved word in JavaScript. And also, you can actually execute JavaScript inside of your JSX, essentially, once it compiles down. So here we are actually using the props object that was passed in, and it's going to render the thumbnail, the name, and the price that was passed in. So these item components are going to be rendered inside of cart. The cart is like a parent wrapper component that knows about some more business logic. So it's going to render all of the cart items. And it's also going to render the proceed to checkout button. It's going to render the total, which it calculates based on the data from the items in the cart. But the cart does something really, really important to this whole flow, and that is it knows about what data it needs. And the way we're going to do this for the universal app architecture is we're going to put the static function on any component that's going to need data on the server. Because in the browser, we can fetch data asynchronously, and that'll be fine because then it'll just update React. But on the server, we only get one shot at it. We need to have the data before we render the components. Because remember, we're just rendering them to a string. There's no JavaScript there. There's no virtual DOM there. We're just creating the output. So we have to get the data first. So this is going to enable us to know what data to get on the server. So in this case, we need to get the cart items. You might also need to get the user or get products or whatever else for this app. But those would be in other components or other parts of the app. The cart component also hooks up to Redux. That's so that once that action is called, it knows how to fetch the data out of the store. If it doesn't do all of this, it won't know. The connect function in Redux is a higher order component in React. It wraps our cart component and talks to the Redux store for us and manages all the state updates so that our component just ends up with the props. So let's look at the actual action real quick before we get to the server code. So we actually have this function. We call it an action creator. It ends up dispatching a Redux action. So it uses isomorphic fetch, and which is basically a wrapper around the fetch API that lets you use fetch on the server. You could also use request or super agent or whatever you'd like that works isomorphically. We're fetching from a sample API that's on the server here. It's just a mock API that has reads some JSON in. Once it gets that, it's going to get the data out of the response and then dispatch this action. And this action has a type, get cart items, and it has the actual items. Those items are then, that action is then sent to the reducer. And the reducer takes in this action, it takes in the current state or the store, and it returns a new copy of that state based on what it's supposed to do with that action. So in this case, we want to update the items in the cart store. Okay, so that's pretty much all the code that's going to be used in both environments. But we also need to set up our server. most of this is setting up our server middleware so that we can output some HTML, right? It's pretty straightforward. We're going to get this HTML, and then we're going to send it to the browser. So to do that, we have this middleware, which we talked about a little bit earlier. First, we got to set up Redux, get the store. Then we need to grab those actions, right, off of load data on each component. And we do that dynamically because we don't know what route we're going to be on, right? Then once we get all of those actions, we need to dispatch them. In this case, they're all set up as promises with Redux thunk, so we wait for all of them to come back. This is assuming your actions are asynchronous. It's a little bit easier if there's synchronous stuff, but this assumes you have data needs that are not on your server. So once they all come back, each action will update the store, right? Earlier we talked about that, right? Redux will call the action and then call the reducer and update the store. So once we know they're all done, we know that we have the accurate state in the store. And so we get the current state of that store. Then we're also going to stringify that state. If you remember at the beginning, I was talking about we need to send the state down to the browser. So we need both versions. We need the version we're going to build the components with and the version we're going to send to the browser. Then we're actually going to build our components, finally, right? So here we use the Redux provider component and the React router context component to set up our app, which makes Redux and React router work in our app together. We pass in the routes, we pass in the store, which is the initial state, and the render props that was returned in this callback is how we know like what the component tree looks like. It's basically a React router talking to itself. There's a bunch of things on that. But we need one more step, because if we just sent that to the browser would be like, this is not valid HTML because it doesn't have like a head and a body, and I don't know how to parse this. So you can do this a bunch of different ways, but the way I've done it here is to make another React component and just take that those outputted pieces and the server state and render them into a HTML React component. And then we send that down to the browser. So that HTML React component is actually a weird React component because we're only going to ever use it on the server, which is strange, right? So it has our standard index.html structure. It's going to let us set our React content inside of our React content div, and then on the browser we're going to render the hydrated stuff into that div, and React will be like, yay, it matches. We're also sending on the state and a script tag, so we can just pull that off. And then if you remember, we made that browser.js bundle way back with Webpack. We're going to send that down too, so the JavaScript actually runs in the browser. So at this point, you'll see something. That's cool, but the JavaScript won't actually work yet. If you... So, well, it will. But if you take the script tag out at this point, your JavaScript won't work. So that checkout button won't do anything. It's supposed to route to a checkout page. But you do have a serialized state here that you can see, you can parse off the window there. So that's useful if you want to check out the handoff there. So we just have to do one more thing at this point, which is we have to hydrate the React app in the browser. So we grab that initial state, and we initialize Redux with it. So Redux can actually be set up with a starting state. And that means that we don't have to do any data fetching for this first round. Then we render React. And because we're rendering React into that div, the React content div, and because we have the exact same state we had on the server, React is going to be able to say, oh, I match, I'm happy, I don't have to do anything. This is really good for this kind of flow. So if you want to check this out, you can set a debug point in that main.jsx, and you can see oh, okay, the app loaded, but the JavaScript hasn't loaded yet. Then you can step through and see what happens. I find this useful to understand like concretely how this flow actually fits together. Okay, so let's talk about some of the hard parts of this, because there are some harder parts. So one problem is you're actually using two different environments, right? The server and the browser are very different. The server has things like process object. The browser has things like window and document, and these things are not compatible or available in the alternate environment. So I like to think of this like this: Batman versus Superman. They argue with each other. So one strategy you can take is you can actually create the process.env object using Webpack. Webpack is good at like polyfilling things for you, and you can do like a browser boolean on it. And then if you truly have something like you need to talk to the window because you need to talk to a third-party library that only runs in the browser, then you can hide your code with this, and it won't run in the server. You can also use component did mount in the React lifecycle. If it's not something you need to do on the initial load, that works well too, because component did mount will never run on the server. Performance is also a challenge on the server. Unfortunately, rendered string is not the most performant function in the world. And as you get more complex pages with many small React components in them, it can slow down a bit. Now, server performance might also have problems because maybe your API is not sub 80 milliseconds. Maybe it takes 200 milliseconds to come back, right? In the real world, not everything is always as perfect as it should be. So there's some strategies you can take for this. Depending on your needs and your SEO needs, you can try to only render above the fold content on the server. Now, if you're really doing this for SEO, that might not be the best idea. But if you're doing it more for like perceived performance, you can get away with that. You can use streaming. I have not tried this, but theoretically, this is a thing you can do. So you can start sending down the response before everything is actually done. And then you can use caching. But caching is a whole own topic. I could probably talk about caching and isomorphic app architecture for a whole 40 minutes by itself. So really quick, why would you want to use caching? Because it hides your server problems. And also, when this happens, when you go from one user to like a bunch of users, it also saves your server from getting overwhelmed. So you can do CDN edge caching, or you can do in-memory caching. If you're going to go the in-memory caching route, Walmart Labs has a server-side render cache library that looks super cool. I've not had a chance to try it out, but it looks like it offers some really good options for improving your server performance. And it's fairly granular, so you could do like sub-parts of templates and pages. But let's talk a second about the CDN and edge caching. So this is a really useful tool, and it will protect your servers. But remember how we've been talking about how this is a user who comes to your server, and it's like we're getting their cart? Well, if you have edge caching, then you're going to have a problem in that case, because every user needs their own version of the cache, right? Because you can't have bleed between users. So in fact, what we do at Vivo is we only ever do things with your user once we get to the browser. This is a trade-off. It's not perfect. It means that certain things load a little bit slower, like detecting whether you're logged in or not, but it means that we can load the majority of the page very quickly. So I think this is one of the really hard problems with universal web apps, and I don't think that there is like great, amazing solutions for it yet, but I think it's something that, since it's becoming more popular, is something as the community we can solve. And then, as you've seen, there's like a lot going on to get up and running with this, right? And this is a trade-off. You have to learn a new way of thinking, and you have to understand how to set up all these pieces, understand all of these different libraries. Walmart Labs actually has an out-of-the-box solution. There are a couple other libraries out there that have out-of-the-box solutions, so those do exist if you just want to try it out. But I would say that there is a major trade-off here. Like, we've used Redux in our app, and now we're using GraphQL also, and so we wanted to move to using Apollo, and because we had granular pieces that deal with distinct areas of the app, it's actually been fairly painless to switch. And so despite this complexity, you do get a lot of long-term advantage to being able to evolve your app to your current needs. So if you remember just one thing today, building universal apps requires you to think about your application flow in a new way. Despite all the details, all the libraries, this is really just it. The user flow is a little bit different. And if you learn that user flow, then you'll be able to build an app like this. And that's it.